Greetings, detectives. Mrs. McKay here, and we're going to work on Clue 2 of Case 8. And this is all about interpreting data and being able, when you're looking at a histogram or a dot plot or a line plot, and being able to describe the representation, the distribution, and determining whether it's a skewed or a uniform or symmetric. So let's go ahead and start by first writing in our learning target. I can interpret a histogram, so write the word histogram. By describing it as uniform, symmetric, or skewed. So make sure you have that written down. Now let's just do a quick little review of some words or some terms. Dot plots, also known as line plots. You'll see them used both ways. Right here, where it says skewed distributions, that is a line plot or a dot plot. Basically what we're doing is we're putting a dot or an X or some marking above a value every time that value occurs in the data. Okay? And then histograms are similar to dot plots or line plots, except that dot plots and line plots are usually for every individual value, and histograms sort of have a range. So they won't just be representative of one number, they'll represent a range of numbers. Okay, so maybe from 1 to 5 or 1 to 10. And so each bar, colored bar, will go up to show you the frequency, but the range of each bar, or what we call a bin, will be more than one. Often it's like 5 to 10, or sometimes it's even more. So those are dot plots and histograms. Now let's talk about how we can interpret that data. So one type of distribution, meaning how the data is spread out, the distribution is how it's spread, is called a skewed distribution. Skewed. And what that means is that skewed is pushed to one side or another, okay? So, or thinned out from one side to another. So when you look at this picture right here of this data, this line plot, you can see that I have many markings on the left-hand side, but as I move towards the right, as I move in the positive direction, that it gets less and less. So this is skewed, meaning that it's not really evenly distributed. There's more on one side than on the other. And the way that we describe something, we describe it as skewed positive or skewed negative, or sometimes we say skewed right or skewed left. Now, a common mistake that people think when they look at skewed data is they would say that it's skewed in the direction where there's the most. But the truth is we always say that it's skewed in the direction of the tail. So if you think about this as a little animal, you can see that it has a little tail. Over here is its tail, where it gets smaller. And so wherever the tail is, that's what we say. So we say that this is skewed right or positive. Okay? And then we can do the same thing with a histogram. And again, we're going to look for the tail, and you can see that again, it's skewing to the left. Okay? Or you could say negative. So, skewed means that it's kind of sliding off. There's a tail on one side or the other. All right? And that usually means then that if we were going to look at the median, the middle number is going to be more towards the fat side, not towards the tail side, right? So it's moved over, all right? It's moved over in the opposite direction of where it's skewed. So that's skewed. Now, take a look at my next histogram. this histogram is uniform because for the most part, all my values are very close to the same amount. So uniform means that they're all about the same. If you think about when students have to wear a uniform to school, it means that they wear the same clothing, right? And that's what uniform means in a histogram. They're all about the same value. You can see that they're not really going up very much. They're very close to the same value, okay? And then the last one that we would use to describe a distribution or a graph would be symmetric. And symmetric means that if I could divide it down the middle, right, then it would be pretty much the same on both sides. It might not be perfect, but it's going to be pretty symmetrical, and you can see that they're very close to being mirror images. You'll also hear people call this a bell curve. Okay, and that's because it makes the shape of a bell. All right? Now, not every symmetric graph is a bell curve because it could look like this. You can see that it's symmetric, but it's not a bell curve. It's actually almost a U-shaped curve, isn't it? So symmetric is the broader general description, and a bell curve is an example of a symmetric distribution. All right? And you'll hear a lot about bell curves when they start talking about grades, curving grades. They try to make the grades fit into a bell curve. All right, so we've got our 3 different types of descriptions: skewed, uniform, and symmetric. And now it's time for us to do a little practice and look at a list of grades from a teacher. And the students don't have names. The students just have letters that are assigned to them. But we're going to take all of these grades, there's 26 grades, and we need to plot them on this line plot. So I think I'll use blue as my color, and I'm just going to get started. And A is 85, so I can, and my X's are going to just be dots because I think that I'm going to have to make them very small. B is 89, so if this is 85 and this is 90, 86, 87, 88, 99, maybe right about there, okay? And then 66 would be right about there. And then, actually, I think I might, yeah, I think I'll do it that way. Then 74 would be right about here. And 77 would be right about here. And 72 would go right about there. Okay, so I'm going to pause this and finish it, and you go ahead and finish it up as well. Okay, so I realized that I wasn't really helping you with figuring out these intervals, so you have to put 4 hash tags or hash marks in between each one. So we go 50, 51, 52, 53, 54, 55, 56, 50. So the 50, the 55, the 60, the 65, they're on the gray mark, but I put little blue marks in between. So I just wanted you to be aware of that, and I erased, and I'm going to try again to make these a little bit more accurate. Okay, so let's take a look at this. I went ahead and enlarged it so that you could see a little bit better and so that I could write a little bit easier. I think I did this right. I should double check it. Yep, it looks pretty close. So it's a little sloppy, but you get the idea. So now what I want to do is I'm looking at these grades and I need to decide, I want to describe it. All right, I want to describe it. So is it skewed, is it uniform, or is it symmetric? Now your first thought you might say, well, it looks pretty uniform to me. It's not very high. But when we're looking at such a large spread between 51 and 98, which is our highest and our lowest, we need to kind of also think about where are the majority of our dots on this line. Where's the majority of the data? And you can see that the majority of it looks like it's over on the left-hand side. So it kind of looks a little bit like this. Right? So it's skewed. Can you see how it's skewed? It's pushed in one direction more than another. And would you say that it's skewed right or it's skewed left? Well, it's skewed right because we're looking at the tail. And the tail has all of this entire section here that it's just one data point, where on the left-hand side, there's more than one data point. There's 2 and 3 data points, okay, for each score. All right, so now let's go ahead and work on creating a histogram. And we're going to take our information, which we have in our line plot, and we're going to turn it into this histogram. And the histogram is going to be groups of 10 or more. And since our scores start past 50, we're going to go ahead and we're going to put this like here. That means that we're kind of scrunched up the 0 to 49. We've scrunched it up because we don't have any data there. So that little squiggle line tells us that we're doing everything in between 0 and 49, all scrunched up in that area, and we're really starting our graph at 50. All right? So see if you can take your data points and count up how many you have from 50 to 59, because 60 starts the new data, the new bin. Okay, so this is going to be 50 to 59, and then 60 to 69, 70 to 79. So see if you can create this histogram using the information from our line plot. Okay? Okay, so before you actually start counting up, make sure that you've labeled your graph, your table, your histogram, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is the frequency. And these are the test scores. Okay, so we want to make sure things are all labeled. Now let's go ahead and get this figured out. So I'll do the first one just to get you started. So from 50 to 59, we have 1, 2, 3, 4, 5, 6, 7 occurrences of a score between 50 and 59. So that means I'm going to fill in my first bin up to 7. Now you go ahead and finish. Okay. And once again, if we look at our data, this time in a histogram, you can see that I created it. I just used the same color. Notice on this one in particular, from 80 to 89, there were 1, 2, 3, 4. You might have been tempted to make 90 be in this bin, but it's really in the second bin, which means that this right here needs to be a 2, not a 1, because 90 is the start of the next bar. Okay? So again, you can see that this is skewed. It's skewed right, the same as it was in the dot plot. You can see that the tail comes down, and so it's skewed right. a big fat marker right now. And that's how we describe our data, okay? And then we can make